everyone, and welcome to the May edition of the Georgetown Center's Business and Public Policy's Lunch Nugget. Thank you all very much for joining us. We are very excited to feature our guest, Peter Rysavy, who is the founder of Rysavy Research. And I am ably assisted in my co-hosting duties by Jen Fritchie. I assume you are out in Chicago.
I am. I have to tell you how modest Peter was because I promoted this session, labeling him as one of the brightest minds in wireless, and he disagreed. And I'm not sure I've met a better one. So, so we're excited to have him today.
Thank you. You're very kind.
And Peter, before we let you share a few more details about your background with folks on board today, I just wanted to orient everybody's attention. There's a lot of discussion going on right now, especially inside the Beltway, but not limited to DC, on what is the path forward for spectrum. Whether you are looking at this from a license perspective or not, it is a critical conversation. As we know, just recently, the FCC chairwoman has let the Hill know, Congress know, that in fact there is no identified spectrum pipeline. So in terms of where the growth is going to come from to support, let me just get a stat here, which I thought was really compelling. And that is, I think it was April 2022, 5G America's CEO put out a new piece. And in it, he was citing to a report, it may have come out from Cisco, that was estimating that global mobile data traffic is increasing at a rate of 40% year over year, which just by itself might not sound that impressive. But when you think about the kind of capacity demands that puts on the networks, I think Chris's other comment was the fact that this could put network operators in a position of having to increase their capacity every 20 months to stay ahead of that demand. And the demand is obviously continuing to grow. So Peter, what we want to talk to you about today is this concept of sharing. What is it? It's a term that's really being thrown around DC a lot as potentially the perfect answer to all of our spectrum demands and needs. And I was hoping that you could enlighten us as to exactly what is this thing that they're talking about, what is simple sharing, complex sharing, what have we learned, is there sharing that's actually happening that's effective, are there experiments that have been conducted that are not effective? Want to get into all of that for folks, but first and foremost, Peter, if you could just share a few items, highlights, if you will, from your illustrious career working in this space.
Sure. Well, in fact, all spectrum is shared, but the way you share spectrum, the way different users or devices or entities share spectrum varies tremendously. At a high level, if one country is using spectrum and another country is using the same spectrum, that is in effect spectrum sharing. It's just that they're using it in different places. But when people refer to spectrum sharing as a way of augmenting capacity, they're really referring to being able to find spectrum that's used by one party, say the government or Department of Defense, but where the incumbent is not using it very often. So the thought then is, well, maybe other entities could use that spectrum when the incumbent is not using it. So then we're looking at complex mechanisms for dynamically sharing that spectrum.
So Peter, before you go, you just give our guests just a sentence or two about Rysavy Research and the length of time that you have spent thinking about mobile networks, spectrum-based networks, which are not always mobile. And then I think you have a rather interesting deck that might be great for people to see. I think if you just press that little green button that says share screen, you should be able to pop that up, and then the rest of us will be minimized to little tiny squares. Okay. And that way it might make, I just think when we talk about the engineering of all of this, I always find it super helpful to be able to look at a visualization, not being an engineer myself.
Sure. Well, just a little bit of background. I've been working in mobile wireless for almost 30 years now. And for the past 10 or 15 years, I have been analyzing the trajectories of different wireless technologies, their capabilities, and a large part of that is what kind of performance or capacity can they achieve based on the technology and based on deployment configurations. So really a lot of my work is looking at, if you have this much spectrum, what does that translate to in the marketplace? What can users do with it? Carolyn, you mentioned that there's some 40% growth. That is an incredible challenge for operators, because to increase capacity, it's not like they can just install magically through some software upgrade some capacity enhancing feature. What it really means is that the operators have to either densify their networks, deploy more cell sites, deploy more efficient technology, but there are only so many ways you can make wireless technology more efficient, or access more spectrum. And so all of those have to be done at the same time, but being able to access more spectrum is a large part of the solution. So let me now share my screen here and quickly go through this PowerPoint presentation. And okay, so you should be seeing something.
Hey, Peter, while you're doing that, are you on a mobile connection?
No, I'm on a wireline connection. Am I having
I'm
sound
sorry,
problems?
we can't hear you. It's very jittery.
I can hear him fine. Carolyn, might be your connection. I can hear him fine.
Okay, I'm going to keep going. Yeah, and Carolyn, you were dropping out before too, so it is possible that's on your side. All right, this is a subset of a presentation that I have on my website, and you can access it from rysavy.com/spectrum sharing. And it's also available from my website at the tab Writing. And there I have multiple resources related to spectrum sharing. This is a topic I've written about extensively over the years. The nature of sharing a radio medium, I have just two examples here: a cellular network where a cell tower coordinates access, and Wi-Fi networks where devices sense each other. So both of those systems are a way for multiple users to share the spectrum, but they're homogeneous systems in that the cellular network uses one set of mechanisms and a Wi-Fi network uses completely different mechanisms. But in an effort that would allow cellular users and Wi-Fi users to share the same spectrum, engineers came up with a way for cellular systems to actually be able to use unlicensed spectrum. And that turned out to be an incredibly difficult problem and exemplifies what I have concluded about spectrum sharing, which is that, yes, it can be done, but today's technologies are really restricted to the types of systems involved, meaning that if you design a spectrum sharing system, it will be for A and B to share, but if a C type of system wants to be involved, they're out of luck. The dimensions of spectrum sharing, really, the simplest is geography-based. I already mentioned that different countries use the same spectrum, or it could even be in different states or different licensing areas. In fact, cellular systems themselves, for the most part, avoid using the same frequencies in adjacent cell sites and reuse the spectrum at some distance away. And that has to do with the fact that you can interfere with the signal for like 2 to 3 times the distance than you can actually usefully use the signal. That's the simplest approach, and that is used everywhere all the time. Frequency-based sharing is how spectrum is allocated to operators and different users today, where different users share different bands. But when people talk about spectrum sharing nowadays, they're often talking about time-based sharing, where in real time you alternate who gets to use a spectrum. And that turns out to be an extremely difficult problem. And you can get a sense of how difficult it is. The Citizens Broadband Radio Service, CBRS, it took 8 years to go from the initial notice of proposed rulemaking to auctions for the priority access licenses. NTIA, in a study, concluded that spectrum sharing technologies can take on the order of a decade So those are the timeframes that are not unusual in developing new spectrum sharing approaches. Here's
So Peter, let me just ask you, let me interrupt for one quick second and just ask you real quick. If it takes upwards of 8 years to develop a very specific sharing mechanism that, I think you'll understand, as you'll explain, is still under development in many respects, how does that compare to when spectrum is allocated through an auction? When we think about, so for example, the AWS or the C block auction, where you are given a clear set of rights to use the spectrum as you see fit, subject to build out obligations, without needing to worry about anyone interfering with you.
Yes, exactly. In contrast, if you license on an exclusive use basis, then that spectrum can be brought to market much faster. Sometimes there are incumbents or people who are using the spectrum previously, and they have to relocate themselves. And that can take some time, but we're talking about a process that may take a couple of years versus the 8-year timeframe that I mentioned for CBRS.
Right, thank you.
This is just, I'm not going to go through this whole table. This just goes to show that we've already developed a lot of different spectrum sharing solutions, but each of them really just addresses a specific scenario for specific systems with specific parameters. And that's really the takeaway for spectrum sharing. We don't today have any spectrum sharing solution that is general purpose that can be applied to arbitrary systems. And so some of the adverse consequences of spectrum sharing is, if you insist on it, is that you are going to have longer time to deploy any spectrum sharing based approach. The system is going to cost more because it's more complex. And not only is it more complex, but you also have this problem of lower economies of scale. For example, CBRS is an approach. It today is the most complex spectrum sharing system in the world, and it's only used in the United States. So you don't get the global economies of scale that you do for infrastructure equipment, for handset equipment, and so forth. And ultimately, shared spectrum is harder to use, and you will end up with a system that is not used as much. So this doesn't mean that we shouldn't use spectrum sharing in the future. It just means we need to be realistic about what can be achieved in what kind of time frame. AWS-3, Advanced Wireless Service 3, that's the license bands for cellular at 1.7 and 2.1 gigahertz. And this is an example of simple sharing. And it's based on geography where specific federal satellite uplink stations are protected. So this allows very rapid deployment of new users, in this case, cellular operators, while protecting incumbents. And in contrast, complex sharing is where a cellular system would share with the Wi-Fi system, as I already mentioned. We developed this, or engineers developed this for LTE initially with a system called License Assisted Access. And then in 5G, there's something called NRU, New Radio Unlicensed, that can also access unlicensed bands. This took a tremendous amount of coordination between the Wi-Fi community and the cellular communities. Engineers worked on this for years to be able to get this to work. And ultimately, the way it worked was that the cellular system looked like a Wi-Fi system to other Wi-Fi systems. But achieving that was an engineering marvel, really. Here is another example of a complex system. CBRS already mentioned. It has 3 tiers, 3 types of users. The base stations have to register, request spectrum. There's a centralized database that dynamically coordinates access. There's an environmental sensing capability, which is a network of sensors that detect radar usage. And the incumbent here is Navy radar. The idea is that if the Navy needs to use a spectrum along the coastlines, they just start using it. And then the CBRS system detects the usage and then informs the commercial or anybody using that spectrum to stop using it. CBRS does achieve certain objectives, but it is not a good solution for wide area cellular because of the complexity initially, and then also the fact that it has small license areas and operates at much lower power than regular cellular. So that concludes the overview. And as I said, this is just a subset. I have a more complete deck available on my website. And I also have a separate PowerPoint deck for advanced spectrum sharing concepts where I talk about new developments in spectrum sharing.
Peter, I think the main takeaway from your slides, which were great, is that this is not easy. It might, it's very complex. And is that how are the carriers approaching this? I mean, it's the best evidence of that, seeing what CBRS proceeds from the auction, I guess almost now 2 years ago, were versus C-band. I mean, it was clearly fraction of what carriers paid for C-band. Is the carrier still always prefer what they can own, control in their own licensed spectrum?
Yeah, to your point about the auction results, there was on a per megahertz basis, C-band, which was licensed for exclusive use. The market valued that kind of spectrum 4 times higher than CBRS. So yes, for anybody or any operator that is trying to deploy a nationwide network with widespread coverage, reaching almost all of the population with consistent service, and addressing issues such as constantly increasing bandwidth demands, having the difficulty of not being able to put cell sites anywhere they want, users that are moving in and out of coverage, being able to provide that kind of consistent service over that geography with high throughput speeds, it's a very difficult problem. And really, the only way you can solve it today with available technologies is with a reliable foundation of spectrum that is interference-free and that an operator can depend on for providing the capacity they need.
Peter, do you have, in all of your research and some of the reading, where does the U.S., or can you share a little bit about where the U.S. stacks up relative to other, our big trading partners, or, you can just do it even on a continent basis, in terms of the spectrum we've made available for licensed use versus the spectrum we've made available for unlicensed? Any idea where we stand? Are countries, more licensed than unlicensed? Are they more unlicensed than licensed? But any color or context you can give us?
Yeah, I think it's worth mentioning, first of all, that the market really needs both licensed and unlicensed spectrum. They address totally different needs. There's no way that cellular, for example, can replace all Wi-Fi usage. That's just not going to happen. But similarly, you cannot build out wide area coverage networks with Wi-Fi technology. That's never going to happen either. They really address different needs, and together they provide the kind of optimum blend of performance and coverage that users expect today. As far as the amount of licensed versus unlicensed spectrum, until recently, the US had a fairly even balance between licensed and unlicensed, but with almost a gigahertz of new spectrum allocated for 6 gigahertz, that really changed the equation. And right now, more spectrum is available for unlicensed than licensed, and I believe by and large more so in the US than in other countries. I don't believe most countries have allocated as much spectrum at 6 gigahertz, but I don't have a detailed table in front of me.
Sure. And so when we're, Jen, I'm going back to, when we used to do these Wall Street conversations here in DC. When you look out past the 2.5 auction, which is the only other one scheduled, and that's for very small slices in a very fractured allocation, so therefore not of widespread interest, and certainly not will be anything like getting the spectrum that we got, that the companies got, not we, the industry, got through the C-band auction. The question is, where is the spectrum going to come from?
That's going to be challenging. Different groups have identified various possible spectrum opportunities, but below 2.5 gigahertz is just slivers of spectrum. Probably the biggest opportunity right now is from 3.1 to 3.45 gigahertz. That's 350 megahertz of spectrum. But beyond that, the rest of the world is looking at 4.8 gigahertz, but I don't think that has any momentum in the United States at this point. There's some satellite spectrum at 12.2 gigahertz, but there are already different entities that have claims on that. The good news is that there's a huge amount of spectrum available above 95 gigahertz. The bad news is we don't know how to use that spectrum yet.
Right.
Peter,
And so,
go
ahead, Jen.
Carolyn, in the lower three, I mean, the DoD does occupy that spectrum, and a careful reading of the infrastructure bill would suggest that if that is ever dealt with, it still have a shared component. Do you have an opinion there?
There is an industry / government, including DoD, effort underway right now, being coordinated through a National Spectrum Consortium. I believe that's what NSC stands for, but you can check that. I just see NSC in all the documents. But they're looking at how can that spectrum be used. There are some incumbent DoD systems where DoD has indicated that relocating them elsewhere is going to be extremely difficult. So spectrum sharing is on the table, but nobody has concluded that CBRS, for example, is up to the task. And we have to remember that CBRS was designed for sharing with very specific radar systems. So it's possible that we could reuse some aspects of CBRS, or could be an entirely new spectrum sharing approach. So that is something that is under investigation, and there are a lot of different organizations involved in analyzing this problem, but it is a complicated problem.
And Peter, what would you say to folks, and usually this comes from manufacturers and others who would say, you know what, everybody just needs to have better receivers. We need to have, there's more we can be doing with our equipment, both on the CPE and on the network level, where we can extract more juice from the spectrum we have. I based on the conversations I remember you and I having over the years, maybe there is some additional efficiencies that can be extracted, but at the end of the day, we just need more spectrum if we're going to truly realize the capabilities that are being built into 5G. And then, I know we're a little bit away from the standardization around 6G, but there's a lot of conversation about, well, what does 6G look like once we have 5G fully implemented? Is that still your take on it? That at the end of the day, yes, we need to be doing all of these things, but we also need inputs of big swaths of spectrum?
Absolutely. It's all of the above. When we went from LTE to 5G and were able to commoditize massive MIMO, massive multiple input, multiple output, where you have antenna arrays, that approach did significantly boost both capacity and coverage. In a dense network, you can get at least a threefold improvement in capacity through that type of antenna technology. But that only takes you so far. We're really reaching limits of physics as far as how efficient the technology is. So once you've made the technology as efficient as possible, and then Carolyn, you also mentioned receiver standards, there's other things you can do on the edges, but there's only so far you can go with technology. Beyond that, you have to either densify the network, which means a lot more cell sites. And that is happening. The number of macro sites in the US keeps increasing, and we're getting better at deploying small cells. My projection shows that by the end of this decade, there might be in excess of 1 million small cells. And that's compared to about 400,000 or so macro sites today. But again, that's not sufficient by itself if we keep having the broadband growth. So ultimately, you do have to keep adding more spectrum into the equation. There's just no other way around it.
Jen, I want to do a shout out here to your former colleagues at Wells Fargo. They put out a note, Eric put out a note in which he was assessing, fixed wireless access versus fiber to the home versus, cable. And I think the way he's positioning this as is, maybe the time has finally come where you're going to start to see a larger and faster proliferation of FWA as it's described, or as some people are advertising, home broadband is another way to talk about it. So I'm curious, Peter, that note, which I'll share if you hadn't seen it, is making the case that in terms of what the world looks like from the consumer's perspective, so from the users like me and Jen and you, is that our choices are about to increase in terms of our solutions at home in what our broadband connections are. And I think his estimates are, rather impressive in terms of the net homes that he sees as being added using mobile-based solutions for internet and including in rural America. So Peter and Jen, really, curious what you're hearing or what you're seeing in terms of what is the killer use case for 5G? Is it going to be home broadband? Is it something else?
Well, I think home broadband is one of the killer applications for sure. I wrote a report in 2019 based on a deep dive analysis of the capacity of 5G and different deployment densities, and showed that 5G can directly compete against DOCSIS or cable technologies. Radio will never have the same amount of bandwidth as fiber, but it's not wireless versus fiber. The way to look at it is that we're just extending fiber through the environment and closer to endpoints all the time. And every entity is doing that. Mobile operators are doing that. The cable companies are doing that. That's just the way things are going. The question then is just how do you connect that last 100 yards? Is that right? A 5G radio? Is that cable? Or do you run the fiber all the way to the house? In a rural setting, running cable or fiber to the house doesn't solve the problem of a farmer needing broadband coverage across their entire farm. So fiber to the house is not necessarily what you want in every situation. As far as other killer application, I'm a big believer in extended reality, augmented reality, virtual reality, metaverse. All that is going to happen. It's just inevitable. That's the nature of technology. Once we can visualize it and see the potential, then it's just a matter of time until we get there. I think industrial IoT is going to consume a massive amount of bandwidth. So I think that's another killer app. Smart cities, autonomous driving. We're just in early days with all of these, and it's hard to predict exactly which will be the biggest, but they're all coming. That's just going to happen. And I'm sure Jen has some perspective on that as well.
I would agree with all of that, but I'd also point out like 4G had to come first before Uber was enabled. So I think there's business cases that we don't even know that yet exist, but the technology has to come to enable them. So I think that's absolutely correct. And it's an exciting time.
I was laughing because, Peter, you mentioned one of the things you think will certainly consume capacity and maybe even drive demand is virtual reality. And given that I'm based in DC, I feel like I live in that already. We are oddly on time, which I know we've been trying in the last year of doing these events, Jen. We've been trying to keep it to 30 minutes. But I wanted to just kind of pull this together because we did want to make it crisp and clear for folks that are joining, just given the fact that so many different people are talking about spectrum and sort of what are the next steps. And if I heard you correctly, Peter, what you're saying is we need an all of the above approach, right? We need unlicensed and we need licensed. And as you pointed out, those two different ways of assigning rights or lack thereof to spectrum serve two very different needs. Both of them are important. At the end of the day, it sounds like our discussion as to what is an effective sharing mechanism is going to be based on band by band, that currently there is no overarching single solution for sharing, and that to the extent policymakers are looking at any of the current experiments, such as CBRS, I think what you're pointing out is that was designed for a very particular kind of sharing in a very specific band with a very specific kind of incumbent, in this case, Navy radar. And that therefore, one should not assume that that solution, it can be exported to other bands with other and different kinds of incumbents. But at the end of the day, we need more spectrum, no matter how much we're doing around the edges and with the equipment, to really expand and stay ahead of this surge in global mobile data traffic. Was that a
Yep, I
summary?
think that's
Would you
a fair
agree?
summary of what we discussed today. I absolutely agree.
That's great. Terrific.
Well, I
Thank
think
you so much.
we have, Jen, if I'm not mistaken, I think we are slated to reconvene June 15th for our next discussion. As folks can tell, there is a lot to discuss here, not just understanding what the technology terms are and how they work, but I would love to have another conversation, Peter, maybe later in the summer, about these use cases and just get into more details about how much capacity does something like virtual reality on a scaled basis would actually consume, and really get into some of the details around that. I think that would be super interesting.
Okay, I would love to do that.
Peter, you lived up to the billing of the best wireless mind in the industry.
Thank you, Jennifer.
We really appreciate the time you spent with us, Peter. And for folks watching, there was a link where you can find the slide deck, as well as a bunch of pieces, articles, and research that Peter has pulled together on the general topic. So thank you again. I hope everyone enjoys the rest of their lunch, and hopefully we'll see you all in June. Until
Happy
then, have
Memorial
a
Day to
wonderful
everyone.
Memorial Day weekend.
Okay.
Absolutely.
Thanks,
Thank you.
everyone. Thanks, Peter.
Bye, Jen.
Bye.
Bye,
Peter.
Carolyn.
See ya.